Hello everyone, welcome to Z&Z Classroom. I'm Mary, and in this episode, I'm gonna keep introducing you about more transformation stuff. So in the last episode, you probably already learned about the very basic concept of transformation, which include those 10 types. So vertical stretch compression, vertical shift up and down, horizontal stretch compression, horizontal shift up and down, and reflection across X and Y axis. So in this video, I'm gonna try to combine those types of transformation together and see if you can write the resulting function. So for example, I'm gonna give my first example here. And I'm gonna do in an orange color. So my first example here is that first, I'm gonna do a vertical stretch by a factor of 2. So what I'm writing here is gonna be in order. So in transformations, order is pretty important. So I'm first gonna do a vertical stretch. Then my second step, I'm gonna do a horizontal compression by a factor of 1/3. Then I'm gonna do a horizontal shift left 5 units. Okay, I'm not gonna do 1/3 because we already did that before, so I'm gonna do 1/9. So let's just have those three first, and then they go in the order, right? So what I'm gonna do is that first of all, I'm gonna do my first step, vertical stretch by a factor of 2. So I'm gonna having my g of x here. So g of x is representing my resulting function. And I have equal to 2f of inside, I'm gonna have 2f of x. But in this case, I'm not gonna just have f of x because I have horizontal transformations. So I guess the first step, I'm gonna put that here. And my second step, I'm gonna do my first horizontal compression here. So I'm gonna say 2f of, you learn about compression and you know that we're gonna put in a 9 in front of x, right? Because it's horizontal compression, you do the reciprocal of your factor. And then next, which is the last step in this question, I'm gonna do g of x equal to 2 times f of 9 and x plus 5. So in here, one thing to remember is that for this shift, everything for horizontal, you place your transformation next to your x. So why I'm saying that? Because I'm just gonna give you another example, which is different from this one, but a lot of people will miss it. So for example, if I'm saying that I have vertical stretch by a factor of 2, right? That doesn't change. And then, I'm sorry about that. And then I'm gonna have a horizontal shift left 5 units. So basically, I'm kind of switching the order for the last two, but you will be surprised that you're gonna get 2 different answers here. That's why I said order affects a lot in transformation, right? So I'm still going in order. So what I'm gonna do first, the first step doesn't change. It's still g of x equal to f of x, right? But then the second step, I said that you're putting your horizontal transformations really next to your x. So my second step is g of x equal to f of x plus 5, right? And then my last step, why I'm saying that is because my last step is going to be g of x equal to f of 9x plus 5. So see how these two are different here. I'm gonna, it's not a good color. Okay, I think I'm just gonna underline it. So over here, g of x equal to f of 9 parentheses x plus 5. Why I'm putting this parentheses here is because I'm putting this 5 very close to my x, so next to my x. I'm not gonna do 9x plus 5. I'm only putting this 5 next to my x. And then over here, why I'm getting g of x equal to f of gx plus 9x plus 5 is because I'm having x plus 5 first, and I'm gonna putting that 9 next to my x, not next to my x plus 5, but next to my x. So hopefully that makes sense. So as we do more examples, you're gonna understand that more. So let's continue. So I'm gonna give you more examples. For transformation, practice is best tool to help you. So for example, I'm just thinking of the questions right now. So for example, if I have horizontal stretch by a factor of 5, and then I'm gonna have a horizontal shift right 10 units. And then I'm gonna have vertical shift up 5, let's see, 7 units. And then this last one gonna be tricky, which is reflection across the axis. So you will see why I'm saying this is tricky. Okay, so let's see. How can I write my g of x? So the first step, my g of x is gonna equal to f of 1/5 of x, because the reciprocal of my factor over here is horizontal. And then g of x equal to f 1/5 of x minus 10. See, I'm putting this minus 10 right next to my x, not next to my 1/5 of x, but next to my x. That's why I'm putting a parentheses over there. And then next step, I'm having g of x equal to f 1/5 x minus 10 plus 7. Okay, that step's easy. And last step, what I'm gonna do is g of x is equal to, it's equal to negative f 1/5 x minus 10. And what you're gonna do here, you are also reflecting the sign of this plus 7, which you're making it become negative 7. So why you're doing this, it's because this thing is actually, so the original, when you apply this, we kind of ignored this step, is that it's actually negative parentheses f 1/5 x minus 10. Sorry, not that. X minus 10 plus 7. So I'm putting this 7 inside of the parentheses here, which when you distribute this negative sign, you're distributing to every term. That's why my positive 7 becomes negative 7. Okay. However, if you switch these two last steps, so I'm not going to rewrite it again here, but for example, so here is going down. And then my 4 is gonna be switch the last two steps in 3. So what I'm going to do here is that, so these two steps are going to be the same. G of x equal to f of 1/5 x, and g of x equal to f of 1/5 x minus 10, right? But then if I have switched, so the first thing I'm going to do is g of x equal to negative f 1/5 x minus 10, right? So then I'm going to have g of x equal to negative f 1/5 x minus 10. And here I'm shifting up 7 units at last, so I'm plus 7. In this case, my negative sign doesn't have an effect on this 7 because I already put a negative sign there. When I plus 7, you just plus 7. It doesn't matter with the negative sign. However, if I put my reflection after the shift, then the shift is affected by the negative. Okay. And then I'm going to give you another example that involves a horizontal reflection. So let's see, horizontal. So for everything horizontal, put your transformation next to your x. So including this reflection. So let's see an example. Let's see, I have a horizontal. Let me do a simple one. Shift left, 8 units. And I'm gonna have a horizontal compression by a factor of 3/4. So now I'm not just gonna have 1 over something, okay? 3/4. And then I'm gonna have a horizontal reflection. I'm gonna have a reflection across the y-axis, right? So how can I do that? So the first step is g of x is gonna be equal to f of x plus 8. So always remember left when you write it is plus 8, okay? And then g of x is equal to f of 4/3 x plus 8 next to your x, not next to your x plus 8, next to your x. So lastly, reflection across the y-axis. So g of x equal to, so I'm gonna write this really detailed, but later when we're doing it faster, you don't need to write this. So it's gonna be f of 4/3 negative x plus 8. So whenever you're doing across the y-axis step, always putting a negative sign in front of your x, not in front of 4/3 x plus 8, in front of your x. So you're gonna write this as f of negative 4/3 x plus 8. Okay, so some people might also write as f of negative 4/3 x minus 8. I mean, they're exactly the same. They're just getting the negative sign out. So sometimes the teacher might have specific requirements, so listen to your teachers, but these two are the same. So remember everything horizontal next to your x, okay? So that will save you a lot of efforts on trying to figure out whether I should add parentheses, whether I should not add parentheses. I don't know what to do, right? If you remember, do all your horizontal transformations next to your x, you're gonna be good. That's the really good strategy I found after doing all those transformations. And lastly, I'm gonna do a last example, so 6 over here. I'm gonna using all the transformations. So I'm gonna say vertical stretch by a factor of 7/5. Horizontal compression by a factor of by a factor of, let's see, 4/7. And I'm gonna say vertical shift up 11 units. I'm gonna say horizontal shift right 13 units. I'm gonna do a reflection across the axis. Okay, so let's do that. So here, my first step, I'm gonna have my g of x equal to 7/5 f of x. So that's my first transformation is done. Then I'm gonna have g of x equal to 7/5 of my f of 7/4 x. Remember, reciprocal. So my second step is done. And then I'm gonna write, so I'm just gonna write here. G of x is equal to 7/5 of 7/5 f of 7/4 x plus 11. This step is done. And next step, g of x equal to 7/5 f of 7/4. Remember, next to the x. So I'm gonna add my parentheses, x minus 13 plus 11. And my last step, which is my final answer, gonna be g of x with 7/5 f of 7/4. Oh, I'm sorry. I should write something before that. So this step is down. And then I'm gonna have, so I'm just gonna write it here. So my g of x is equal to negative 7/5 because it's across the x-axis. So I'm putting in front of the function. So, okay, I'm gonna write this step out. So f of 7/4 x minus 13 plus 11. So which I'm distributing this negative sign, which is negative 7/5 f of 7/4 x minus 13 minus 11. So that's easy, right? So it might seem complicated over here. I have so many steps, but when you're actually doing it, it's actually pretty easy. So till now, we're still doing in a really just conceptual form, like we're doing g of x and f of x. We haven't really actually defined what the f of x is gonna be, which in the next video, I'm gonna do some real examples of f of x. For example, I'm gonna give you f of x as a quadratic. So you're gonna write in the resulting function after the transformation on that quadratic function. Because in here, I'm just saying f of x. But later, I'm going to say this f of x equal to x squared, for example. Now I'm going to do a series of transformations and what are my resulting function. And that's all for this episode. And I hope you like it. And thank you so much for watching.